A new report on the most dangerous derelict objects in space has just been released. These objects are mostly rocket upper stages and defunct satellites. In the case of upper stages, they may contain pressurized areas and residual fuel, which makes them an explosion risk. Orbital debris impact speeds are high enough to rupture fuel tanks, so explosions are likely for upper stages that have not vented their fuel. Spontaneous breakups that are likely fuel-related have been observed. The last event was on the 6th of October 2024, when a 6-ton rocket body exploded in space. The report lists those objects most likely to cause a debris cloud if a collision occurs and should be prioritized for active debris removal missions. We'll get into the space startups working on this problem later in the video, but first let's look at the problem in more detail. The authors highlight the risk of collisions is increasing due to more activity in space than ever before. Mega constellations require more launches and place thousands of satellites into orbit over time. China, in particular, is notorious for leaving its upper stages in space, and with 2 new Chinese mega constellations currently being deployed, a rapid increase in dangerous orbital debris seems likely. Looking at the top 50 list is dominated with Russian SL-16 rocket bodies with high masses and high altitudes. For instance, the most dangerous object has a mass of 9 tons with 341 conjunctions or near misses. It's noteworthy that, in second place, is Europe's Envisat, weighing over 8 tons with 276 conjunctions. China and Russia are by far the biggest culprits for littering space with rocket bodies. Of the top 50 most dangerous objects, 43 come from those 2 countries. Europe, Japan and the US account for the rest. The average mass of these derelict objects is around 5 tons. This highlights the importance of orbital debris removal missions to clear space of these dangerous objects before collision occurs. The risk of collisions would be halved if the 50 most dangerous objects were deorbited. Just removing the top 10 would reduce collision risk by 30%. The bad news is since the 1st of January 2024, 26 rocket bodies have been abandoned in low Earth orbit and will stay in orbit for more than 25 years. Western countries require launches to deposit their upper stages in altitudes low enough they will be dragged into the upper atmosphere and burn up within 25 years. Companies like SpaceX, for example, routinely deorbit their upper stages over the Pacific Ocean. China, though, typically abandons the upper stage in orbit. China launched 21 of the 26 hazardous objects over the last 21 months. Chinese launches violate international agreements on disposing of rocket bodies safely. With China continuing to launch rockets that leave upper stages in orbit, dangerous debris is set to get steadily worse. Some rocket engines simply can't restart after completing an orbital burn, and even if they could, they may not have sufficient fuel to do a deorbit burn. It's not financially profitable to reserve fuel for deorbit burns as it cuts into payload mass and therefore profit. Unless rocket companies like in the West are forced to do this, they will likely continue to litter space with spent upper stages. Since 2000, China has accumulated more dead rocket bodies in space than the rest of the world combined, according to McKnight, the lead author of the study. Let's look at the trend of satellite launches to see where we are headed over the next decade. NovaSpace report predicts 43,000 plus new satellites in the coming decade. A new report by NovaSpace is predicting a massive number of satellites will be launched into space over the coming decade. They predict the majority of these satellites will belong to just 5 mega constellations: SpaceX's Starlink and Starshield, Amazon's Kuiper constellation, and 2 new Chinese constellations called Guowang and Xifan, or Thousand Sails. In addition to these commercial constellations, both the US and Europe are working on building defense satellites. The US have announced Golden Dome, a network of sensor satellites and end effectors, or satellites that could shoot down incoming missiles in space. This constellation will cost $175 billion, with initial operations planned in just 3 years. There are 2 possible solutions to the increasingly congested and dangerous orbital environment. One is active debris removal, which we'll look at in a minute, but first let's look at another approach. Atomic 6 Space Armour. Atomic 6, a US space startup, is working on highly effective space armor to protect satellites from impacts from orbital debris. The traditional way of protecting against micrometeoroids is a Whipple shield. It's a series of thin metal sheets that gradually slow down and eventually stop an impactor before it can reach any critical systems. Unfortunately, it produces its own debris as small metal shards are scattered during the impact and become a hazard for other satellites. Atomic 6 has developed a lightweight composite shield that doesn't produce debris, making it not only highly effective at stopping impactors, but safer for the orbital environment. Everyone has known that composite materials can make potentially lighter, stronger MMOD shields. Atomic 6 has made that vision a reality with its Space Armour tile, thanks to a combination of product design and composite skills. The Space Armour tiles not only protect vital satellite systems, but offer communications transparency. That means the system can safeguard communication components without impacting their function. Atomic 6 claims on their website that their shields are 10 to 15% stronger and with 85% lower costs than traditional Whipple shields. The company offers their Space Armour in two formats, Light and Max. Space Armour Light is designed to withstand impacts from debris of up to 3 mm, which accounts for 90% of debris in low Earth orbit. The Max version of their armour can withstand impacts of up to 12.5 mm or half an inch. Space startups working on orbital debris removal. A number of space startups are working on the technology to safely rendezvous, maneuver, capture and then deorbit derelict objects in space. Astroscale, a Japanese space startup that I've covered on this channel before, are working on a number of these missions. For example, the COSMIC mission, which stands for Cleaning Outer Space Mission through Innovative Capture, is the UK's first active debris removal mission. An Astroscale spacecraft will use a robotic capture system to seize two UK-registered satellites and deorbit them. Astroscale have already demonstrated rendezvous and an inspection of a derelict object in space with its ADRAS-J mission. Following on from their successful ADRAS-J mission, Astroscale will launch in 2027 a mission to capture and deorbit a Japanese H-2 upper stage, classified as a high-risk derelict object. Astroscale's ELSA-M mission, due to launch in 2026, will attempt to remove several satellites in a single mission. Unlike uncooperative targets, the satellites for this mission have been prepared with magnetic docking plates to make capture easier. ClearSpace, a Swiss space startup, is working on active debris removal and in-orbit surfacing technologies. ESA, the European Space Agency, has commissioned an orbital debris removal mission from them, called ClearSpace 1. The mission will attempt to remove the Proba 1 Earth observation satellite from orbit. Their spacecraft has 4 robotic claws used to grasp the satellite and hold on to it while it is deorbited. Finally, Starfish Space, a US space startup, is also working on debris removal missions. They're working on the technology to capture and deorbit satellites with funding from NASA. In 2027, they will attempt to rendezvous and approach multiple US-owned satellites as a precursor to a later active debris removal mission. Final thoughts. It's clear that efforts need to be increased to deal with the orbital debris problem. It's bad and it's getting worse. In particular, China continues to use launches that leave spent upper stages in orbit, representing a danger to all orbital assets for many decades to come. One major issue is who is going to pay for the safe removal of these derelict objects. Even dead objects in space cannot be removed without permission from the company and country involved. Perhaps some kind of insurance or space tax needs to be agreed between all nations for the cleanup of space around Earth. It's not good to increase the costs of getting to orbit, but unless orbital debris is dealt with, it's just a matter of time before something disastrous happens. How do you believe we should deal with the orbital debris situation? Should space agencies mandate capture aids such as magnetic docking plates to make capturing and deorbiting of defunct satellites easier? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week. or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.